Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss about derivatives and its applications. Are you ready to listen the class? All right. In this lesson, in this project, we have discussed about derivatives such as definition of a derivative, its history, real life applications, and application of derivatives in different sciences. Okay, my dear children? Right. So these are the contents. These are the contents. What are the contents? First one, definition of derivative. Second point, history. And third point, real life applications. And the fourth point, applications in sciences. Okay, my dear children, we discuss all these 4 points today. Okay, my dear children, are you ready to listen the class? Right. Now come to the first point, definition of derivative. What is the definition of a derivative? See, the derivative is the exact rate at which one quantity changes with respect to another. This is a derivative of a function. The derivative is the exact rate at which one quantity changes with respect to another. Okay, my children? Right. Second one, geometrically, the derivative is the slope of the curve at point on the curve. If you want to say geometrically, the concept of derivative geometrically, we say that the derivative is the slope of the curve at the point on the curve. Okay, my children? Right. Now come to this third point. The derivative is often called instantaneous rate of change. This concept is generally used in physics, rate of change in a moving body. The derivative is often called instantaneous rate of change. And fourth point, the derivative of a function represents an infinitely small change in the function. There is a small change in the function. We can find the change with the help of the concept of derivative. Okay, my children? Right. Now come to the next point, that is history. The modern differentiation and derivatives are usually credited to Isaac Newton and Gottfried Leibniz. They developed this modern concept of differentiation and derivatives. They developed the fundamental theorem of calculus in the 17th century. They developed the fundamental theorem of calculus. With the help of this fundamental theorem of calculus, the derivatives concept was developed. This related to differentiation and integration in ways which revolutionized the methods for computing areas and volumes. Okay, my children, with the help of fundamental theorem of calculus, it is related to differentiation and integration. In the differentiation and integrations are used to find the areas and volumes. Okay, my children, right. However, Newton's work would not have been possible without the efforts of Isaac Barrow, who began early development of the derivative in 16th century. Okay, my children, understood the history of the concept of derivative, right? Now, a question arises in your mind. What is the use of derivatives in our daily life? See that real life applications of derivatives. Okay, my children, we are going to discuss the real life applications of derivatives. In which areas we are applying the derivatives. Okay, my children, right. We use the concept of derivatives in automobiles. In an automobile, there is always an odometer and a speedometer. Okay, my dear children, in automobile, there is an odometer and a speedometer. These two gauges work in tandem and allow the driver to determine his speed and his distance that he has traveled. Okay, my children, this odometer and speedometer helps the driver to determine his speed and his distance that he has traveled. Electronic versions of these gadgets simply use derivatives to transform the data sent to electronic motherboard from the tiles to miles per hour and distance. Okay, my children. So in this area we use the concept of derivatives. Okay, my children. Right. So in radar guns, to work the radar guns we use the concept of derivatives. See that, keeping with the automobile theme from the previous slide, all police officers who use radar guns are actually taking advantage of the easy use of derivatives. When a radar gun is pointed and fired at your car on the highway, the gun is able to determine the time and distance at which the radar was able to hit a certain section of your vehicle. With the use of derivative, it is able to calculate the speed at which the car was going and also report the distance that the car was from the radar gun. Okay, my children, with the help of derivatives, we can find the speed and distance. From the previous slide, we got that point. Understood this point, my children? So we use the same concept in the radar guns also. Okay, my children? Right. Not only in the science, in business also we use the concept of derivatives. In the business world, there are many applications for derivatives. We apply derivative in business field also. One of the most important application is when the data has been charted on the graph or data table such as Excel. You know Excel sheet. Okay, right. Once it has been input, the data can be graphed, and with the applications of derivatives you can estimate the profit and loss point for certain ventures. Okay, my children, with the help of derivatives, the businessman estimate the profit and loss at a point where he gets the loss or profit. Okay, my children, right. Now, with the help of derivatives, we have already discussed the graphical representation. The graphical representation, we have discussed slope of tangent. We can find the slope of a tangent at a point on the curve. Okay, my children. So the most common application of derivative is to analyze graphs of data that can be calculated from many different fields. We draw the graphs for any field. In any field, we draw the graphs in business field, in science. Okay, my children, in technology, anywhere we draw the graphs. Okay, my children. Using derivative, one is able to calculate the gradient at any point of the graph. Gradient means slope of that line at that point. Okay, my children. Right. See applications of derivatives in various fields sciences, such as in physics. In physics also we use derivatives. We apply the concept of derivatives in biology also, in economics also, in chemistry also, in mathematics and other science subjects, psychology, anywhere in economics, science, statistics, anywhere we use the application of derivatives concept. Okay, my children, understood? Right. See this point, derivatives in physics. In which area we use the derivatives? In the field of physics. In physics, the derivative of displacement of a moving body with respect to time is the velocity of the body, and the derivative of the velocity with respect to time is acceleration. In physics, you know the terminology, you know speed, velocity and acceleration. So to find the velocity of a body, of a moving body, we find displacement of a moving body with respect to time is the velocity of the body. Again, if you differentiate velocity of the body, the derivative of the velocity with respect to time is acceleration. So to find the velocity and to find the acceleration in physics, we use the concept of derivatives. Okay, my dear children, right? Newton's second law of motion states that derivative of the momentum of a body equals the force applied to the body. Okay, my dear children. In physics also we use the derivatives concept. Okay, my dear children, right? In biology also we use the concept of derivatives. Some students, biology students, why to learn the concept of derivatives, sir? What is the use of concept of derivatives? In biology also we use the concept of derivatives. See here, for example, population growth is another instance of derivative used in the sciences. Suppose n is equal to f of t is the number of individuals in some animal or plant population at a time t. Here, number of animal or plant population is defined in terms of t. Okay, my children, the change in the population size between T1 and T2 is equal to delta n. This is read as, this symbol is read as delta n. Okay, my children, remember this point. Is equal to f of f2 minus f of 1. Delta n denotes f of f2 minus f of 1. The average rate of growth is the average rate of growth is equal to delta n by delta t. Delta n by delta t, that is equal to delta n means f of t1 minus f of t1, f of t2 minus f of t1 by t2 minus t1. To find the average rate of growth in the population or animal or plant, we use the concept of derivatives. Okay, my children, right? Now we use the concept of derivatives in biology also. How can we use the derivatives concept in biology? The instantaneous rate of change does not make exact sense in the previous example because the change in the population is not exactly a continuous process. However, for large population, we can approximate the population function by a smooth curve. For example, suppose a population of bacteria doubles its population n every year, an hour. For every 1 hour, number of populations is n doubles. It doubles for 1 hour for each hour. Denote by n naught the initial population, that is n of 0 is equal to n naught. In general, then we find derivative concept. Okay, my dear children, right? Now come to this point, derivatives in economics. How can we use the concept of derivatives in economics? See, the use of derivatives in economics is as follows. Let X represent the number of units of a certain commodity produced by some company. Denote Cx by the cost the company occurs in producing X units. C of X denotes the cost occurred by the company. Then the derivative of C of X is what's called marginal cost. If you find the derivative of C of X, what you get? Marginal cost. Therefore, marginal cost is equal to formula d by dx of C. We have to differentiate the function C of X. with respect to x. Understood this point, my children? Right. Similarly, furthermore, suppose the company knows that if it produces x units, they can expect the revenue to be R of x. That is, the revenue is a function of the number of units produced. Here R of x denotes revenue from the number of units produced. Then the derivative of R of x is what is called the marginal revenue. So to find the marginal revenue, how much income they get from the units they produce, use this concept d by dx of r. D by dx of r. Remember these points, my dear children. To find the marginal cost, they will give c of x. Okay, the cost occurred by the company, incurred by the company. Then d by dx of c denotes marginal cost. To find the marginal revenue, we have to differentiate r of x with respect to x. Understood this point, my dear children? Right. In chemistry also we use derivatives. We use the concept of derivatives in chemistry also. One use of derivatives in chemistry is when you want to find the concentration of an element in a product. To find the concentration of an element in a product, we use the concept of derivatives. Okay, my dear children. Similarly, derivative is used to calculate the rate of reaction and compressibility in chemistry. So, to find the rate of reaction and compressibility in chemistry, we use the concept of derivatives. Okay, my dear children? Right. Now come to this area, mathematics. In mathematics, how can we use the derivatives? Derivatives in mathematics. The most common use of the derivatives in mathematics is to study functions such as extreme values of function. To find the extreme values of function, we use the concept of derivatives. A function will be given, we have to find extreme values, means minimum value of the function and maximum value of the function. Extreme values means minimum value of the function and the maximum value of the function. To find them, we use the concept of derivative. Understood, my children? Right. Similarly, the mean value theorem. There is a theorem named mean value theorem. In this theorem also we use the concept of derivative. Similarly, monotonic functions means whether the function is increasing or decreasing. Then we use the concept of derivatives. Similarly, concavity and curve sketching. Okay, my children. In this case also we use the concept of derivatives, Newton's method, etc. In these areas we use the concept of derivatives in mathematics. Okay, my children. Right. So come to the point, connecting derivatives. With the help of derivatives, it is related to continuity, inflection points, motion problems, implicit function theorem, estimating graphs. This derivative is connected with all these concepts. Okay, my children? Right. See some other applications of derivatives. Derivatives are also used to calculate rate of heat flow in geology, rate of improvement of performance in psychology, rate of spread of a rumor in sociology. Okay, my children, in these areas also we use the concept of derivatives. Okay, my children, right. Now come to the conclusion part. Derivatives are constantly used in everyday life to help measure how much something is changing. To find the to measure the rate of change, how much amount of changing occurred. We use the concept of derivatives. They are used by the government in population census, various types of sciences, and even in economics. Okay, my children, knowing how to use derivatives when to use them, and how to apply them in every day. Okay, my children, right. Now come to this chapter, application of derivatives. In this chapter, we are going to study rate of change of quantities, increasing and decreasing functions, errors and approximations. Okay, my children, maximum and minimum. In all these four areas, 1, 2, 3, 4. In all these 4 areas, we use the concept of derivatives. Again, to find the rate of change of quantity, suppose let y is equal to f of x, then dy by dx is equal to f dash of x. You know this one. Okay, my children, denotes dy by dx denotes the rate of change of y with respect to x. Remember this point, my children, and its value at x is equal to a is denoted by dy by dx at x is equal to a. This notation denotes the rate of change of y with respect to x at a point x is equal to a. Okay, my children, in the first exercise, we discuss this point, rate of change of quantity. Next, increasing and decreasing functions. Whether the given function is increasing function or it is a decreasing function, we use the concept of derivatives. Similarly, to find marginal cost and marginal revenue, we have already discussed this point in business. Okay, my children, right. Marginal cost is equal to d by dx of c. Marginal revenue is equal to d by dx of r. We have already discussed these 2 points, my children. And to find the errors and approximations, we find errors and approximations with the help of derivatives. Similarly, maxima, minima. The maximum value, the extreme values of a function. To find the extreme values means maximum value and minimum value. We use the concept of derivatives. Okay, my children, understood? Right.